Okay, guys, so here we are on our last day of lesson 3-1. Today we're going to be solving systems using the elimination method. So make sure you have your book open to page 35, something to write with, and your calculator. All right, so let's get to it. So we're on page 35. Here's where we're starting. And today we're going to be talking about another algebraic method that is called the elimination method to solve a system. Okay, so in the elimination method, you eliminate one variable. Sometimes we need to multiply the equation so that the terms for one variable combine to 0. Okay, that's why we call it elimination. You kind of cancel it out. Okay, so we're going to skip this word problem, just jump to these examples on the next page, A, B, and C. And I'm going to get a little more space. They didn't really leave us any room here to do these problems. So let's just do one at a time. So we like elimination method when all of our terms line up like this. So if you see like the x's are lined up, the y's, and the constants, everything's kind of in line with each other. If they weren't in the correct order, we'd have to move them around. But we like elimination method when we have two standard form equations so that those variables, those x's, those y's all line up together, and it makes for easy elimination. So here's how the elimination method works. So we're going to start by looking at our equation, and you can eliminate your x's or your y's. It doesn't really matter which one you pick. You just pick a variable and you stick with it. Okay, so in this case, we have a negative 2x and a negative 5x, but then I have a negative 3y and a positive 3y. So it's looking like the y's are set up for elimination. I call this looking for I call them matching opposites. So matching number, but opposite signs. Because then when I add these two equations together, I just combine like terms vertically. So I'd have negative 2x plus negative 7x, negative 5x would give me negative 7x. And then you can see here, if I have negative 3y plus 3y, those cancel out. Okay, they eliminate each other. So the y's would be gone. I would just be left with equal to 5 plus negative 40 would give me negative 35. So that divides out nice. We get a nice answer of x equals positive 5. Okay, so remember, just like in the last video, we need to make sure we have an ordered pair solution. So right now I got half of my ordered pair. I don't know, it's 5 comma something. I just need to figure out what the y value is. And how we do that is we basically take our x, now that we know that it's 5, and we're going to plug it into one of our equations and then be able to solve for y that way. Doesn't matter which one you pick, just pick one and stick with it. So I'm probably just going to pick the top one. So we have negative 2 times x, but now we know that x is 5, so I can substitute that in. Minus 3y is equal to 5. Okay, so that gives me negative 10. Minus 3y is equal to 5. And then I just finish this real quick by doing my 2 steps. So I'm going to add 10 to both sides. So I get negative 3y is equal to 15. And then that should divide nice, right? So we should get that y is equal to negative 5. So there's our ordered pair, 5 comma negative 5. That's our final answer. Okay, so that's how elimination works, where you line up your x's and your y's, pick a variable to eliminate. And again, it wouldn't matter if I eliminated x's. It just was easier to eliminate y's in this case because they already had those matching opposites. All right, so let's look at B, because B does not have it set up for us to eliminate already. As you can see, I have a 5x and an x. And then we have 6y and a negative 2y. So we don't have those matching numbers yet, but we're going to make them match here. So what we're going to do is this one's going to require a little bit of multiplication. So like I said before, it doesn't matter which one you eliminate. We can eliminate x's or y's. I might just decide to eliminate y's, though, in this case, because I already have a positive and a negative. So I wouldn't have to worry about changing any signs. So we want to make these match. All right, so what we're going to have to do is multiply the bottom equation. Because I can turn a 2 into a 6 by multiplying by 3, right? It's the same thing. So I'm just going to rewrite the problem here on the next line. So just make sure when you're multiplying through, make sure everything gets multiplied by a 3. So this is going to become 3x minus 6y is equal to 30. Okay, now we're set up to eliminate because 6y minus 6y is going to cancel. So then I just have to worry about adding up my like terms here. So 5x plus a 3x, that's going to give me 8x. Negative 14 plus 30, that's going to give me 16. So real quick, I get that x is 2. So we have half of our ordered pair solution. We just now have to find the y. So again, pick an equation to plug it into. It doesn't matter. I might pick this one because the numbers are a little smaller from the original problem where we had x minus 2y. So now we know that x is 2. So I'm going to put 2 minus 2y equal to 10. And then subtract 2 on both sides, move that over. So that's going to give me 8. So if I divide both sides by negative 2, I get my y value of negative 4. So there is that. Okay, so again, always need that ordered pair solution. So find your one variable, x or y or whatever it was, and then once you get that value, you can plug it into one of the original problems. Again, it doesn't matter which one. I just picked the bottom one because I like that it had smaller numbers, but it shouldn't matter there which one you choose. All right, let's do one more together. So we're going to do C here. So I have negative 3x plus 3y is equal to 21. And then I have negative x minus 5y is equal to negative 17. Okay. So again, we're not set up to eliminate just yet because we don't have matching opposite terms, but we're going to pick which one we want to eliminate and just kind of go from there. So if I look at this, right, I can either eliminate the x's or the y's. Now the y's do have those opposite signs already, so that's nice. But if I wanted to eliminate y's, there's no number that I can multiply a 3 by to become a 5, and vice versa. I can't multiply 5 by anything to become 3. So this is a case where you'd have to multiply both equations. Okay, or if I look at the x's, okay, I can multiply this bottom equation and get a 3 as a coefficient by just multiplying by 3, right? So I might just do that because that's less steps for me. Okay, and then remember, if I just multiply by 3, they're going to have the same sign still, so they're not going to cancel out. So if anytime you need to change the sign of it, you just throw a negative in front, and that'll fix that situation for us. So I'm just going to recopy the top equation real quick. And then if I multiply the bottom equation by negative 3, I should get negative times a negative is positive 3x. Negative 3 times negative 5y is going to give me positive 15y equal to 17 times 3. Just do that in my calculator really quick. Is 51, positive 51. Okay, now we're set up to eliminate. So I'm going to go ahead and add those equations vertically where the x's are going to eliminate out. Here I have 3y plus 15y, that's 18y. And 21 plus 51 is going to give me 72. So let's see, if I divide both sides by 18, I get 4 for my y. Okay, so now that we know that y is 4, I just have to plug in to get x. So let's pick an equation. I might just use the top equation. So I know that y is 4, so we have negative 3x plus 3 times y, which is now 3 times 4, which we know is 12, equal to 21. So if I do that arithmetic, I should get that x is negative 3. Okay. So there's my ordered pair solution, negative 3, 4. All right. So let's look at all this together. That is how we solve systems using the elimination method. So all we have to do is make sure our x's and our y's and our constants are all lined up vertically, and then you choose a variable you want to eliminate. Again, try to pick one that's going to give you the answer in less amount of steps, but it doesn't matter if you pick x's or if you eliminate y's. Your work might look a little different if you chose to, like, for example, in C, if you wanted to get rid of the y's, you could have. Your work would have been a little different than mine, but we would get the same answer in the end. Okay, so you guys are going to try one. I'm going to go back to the book page. And I want you to try 17 on the bottom of page 35, please. So give that one a try. It looks like it's already nice and set up for you for eliminating those y's. So give it a try. Combine your like terms, cancel out a variable, and see what you get. And again, make sure you're writing your answer as an ordered pair, x comma y. Okay, if you did everything right, you should have gotten this answer. So you should have got that x was 3 and y was 4. So 3 comma 4 would be my answer. All right, so that is elimination method. So we have learned all of our methods now at this point. So that's all we have to do today. So we've solved systems using 3 methods: graphically, where we look for their intersection point; substitution method, where we plug in an expression into the other problem; and then we have elimination method, which we like when we have x plus y equal to a number. So all your variables are kind of lined up one on top of the other. All right, we'll see you in the next video.